Hello everyone and welcome to Dr. J Tech. I am Dr. J. COMPUTEX Taipei 2025 is having its grand opening. At the same time, NVIDIA's Graphics Processor Technology Conference, GTC Taipei, is also being held concurrently. Among them, the most exciting part is definitely CEO Jensen Huang's keynote speech. What important information did the CEO share with everyone this time? Today, we will introduce it to you in depth. So our topic today is NVIDIA CEO Jensen Huang's keynote speech. There are a total of 10 highlights at COMPUTEX 2025. The first is about the graphics processor GeForce RTX 5060. Then we will introduce the CUDA-X library applied in various industries, as well as the application of graphics processors in quantum computers and the milestones of artificial intelligence, including perceptual, deep, agentic, and physical artificial intelligence. Next, we will introduce how general-purpose robots will open up the next trillion-dollar industry, as well as the GB300 NVL72 and Grace Blackwell, the extreme superchip and customized CPU NVLink's converged silicon IP. Then we will introduce the DGX One and DGX Spark and RTX 6000, as well as NVIDIA's artificial intelligence data platform. Finally, we will talk about the NVIDIA Isaac GR00T N1 humanoid foundation model. First, CEO Jensen Huang mentioned that Taiwan has a strong supply chain and ecosystem. He especially thanked some manufacturers for their assistance to NVIDIA. Then he talked about NVIDIA's transformation from a graphics processor chip to an artificial intelligence infrastructure. Everyone knows that NVIDIA started by making graphics processor chips and later began to integrate chips to create a server system. Then it evolved to provide data center solutions. In the future, it will move towards infrastructure, which is to provide all the system architecture and solutions for large data centers. Next is the introduction of the graphics processor GeForce RTX 5060. From the original large size, it has cooperated with MSI. Finally, it is scaled down to fit into a notebook computer. Next, what you see are all images simulated by Omniverse RTX, which look really lifelike. This is a digital twin of an artificial intelligence factory simulated using Omniverse RTX. That is, first simulate the servers in the data center in the computer. Finally, the actual data center is established. This is a human face simulated by the ASIC platform. As you can see, the simulated face is very close to a real human face, truly lifelike. And the simulation just now used deep learning. The technology of super sampling DLSS is developed by NVIDIA. It is a real-time image scaling technology developed. Through deep learning, lower resolution images are scaled up to higher resolutions. This can increase game performance and improve visual quality. Only 1 pixel is real. The other 10 pixels were guessed by the model. That is, using artificial intelligence neural networks to predict what the other 10 pixels should be like. This can create a lifelike image. Finally, CEO Jensen Huang mentioned that DLSS brought artificial intelligence to this world. Now, artificial intelligence has come back to revolutionize GeForce, meaning only 1 pixel is true. The other 10 pixels are predicted by the model, but the generated image is lifelike. Next, the CEO of the video once again emphasized CUDA-X function library applied in various industries. NVIDIA has spent a lot of resources to assist various industries, use graphics processors to simulate the laws of physics, process data frameworks, and perform computer-aided engineering and deep learning, as well as using graphics processors for computation, quantum chemistry, quantum computing simulation, meteorological analysis and medical imaging, gene sequencing, and combinatorial optimization. Even artificial intelligence RF is applied in wireless access networks, base station related equipment and optical lithography, application in advanced process photomask exposure and numerical calculation. It is precisely because NVIDIA provides these CUDA-X applications that NVIDIA's graphics processors have become the mainstream in the industry, and CUDA-X is a library of functions for various industries. One of the cases is built on artificial intelligence. The 6G network utilizes the NVIDIA Grace CPU and PCIe interface graphics processor GPU and Ethernet connector X7 for accelerated computing. Software and hardware can be designed for wireless networks in the age of artificial intelligence. Design, simulation, training, deployment of AI RAN. The so-called wireless access network refers to base station related equipment. And NVIDIA's Aerial Siona is a link-level simulator that can provide development and training neural network-based 5G and 6G radio algorithms. In simple terms, past base stations could not predict user behavior. By using neural networks for simulation training, Artificial intelligence can be deployed in base station-related equipment. Predicting user behavior can improve the efficiency of the 6G network system. And the vendors on the right are participating in this project, related supply chain ecosystem vendors. Then, CEO Jensen Huang mentioned the future of quantum computers. It contains both a central processing unit (CPU) and a graphics processing unit (GPU). And the quantum processing unit QPU work together. The CPU of a traditional computer and the graphics processing unit GPU can perform pre-processing or post-processing for the quantum processing unit QPU. In other words, NVIDIA is building a hybrid quantum processor and graphics processor computing system. Everyone should remember that the quantum processing unit QPU uses the computing method cannot directly process data, therefore pre-processing is required before inputting data into the quantum processor. After that, the output is calculated by the quantum processor and post-processing is also required. And this pre-processing and post-processing can both use NVIDIA's GPU. That is to say, in the future era of quantum computers, NVIDIA will still play a role, a very important role. And NVIDIA provides related. The function library is called QQuantum CUDA-Q. The main purpose is to assist quantum computers in pre-processing and post-processing calculations. The vendors on the right are the supply chain or ecosystem vendors participating in this project. Next, CEO Jensen Huang talked about the milestones of artificial intelligence. Since 2012, when scientists first used NVIDIA's since the graphics processor developed the AlexNet model. Furthermore, artificial intelligence has developed into perceptual artificial intelligence. And AI can understand images, sounds, and text. Next, developed into generative AI, able to generate images, text, and sound. The scope of artificial intelligence applications has been greatly expanded. Next, it developed into agentic AI, able to perceive, reason, plan, and execute, moving towards a higher level of artificial intelligence. That is, making decisions on behalf of humans and eventually moving towards physical artificial intelligence. Physical AI is beginning to be applied in handling physical phenomena and scientific research, and the current artificial intelligence is agent-based artificial intelligence, including understanding, thinking, and acting. The required computing power is 100 to 1000 times that of a single prompt question and answer in the past. The so-called reasoning AI refers to the system of artificial intelligence based on the ability to solve problems with data, think critically, and perform logical reasoning. For example, I ask AI, "You are my Taipei itinerary planner. Please start from the Taipei Pop Music Center. Plan a 3-hour itinerary that must include MRT and walking. Visit at least 3 of the 5 major night markets in Taipei. Taste 6 different Taiwanese specialty street foods. One of them must be from a Michelin-selected stall. Please list the schedule in detail, including arrival time, stall name, dish name, MRT route and station name, walking distance and route. Explain the source of each piece of information, and finally, use about 50 words. Summarize the highlights of this trip. When the user asks such a question, input into the neural network of artificial intelligence and through the tokens of the artificial intelligence factory for logical reasoning. Finally, artificial intelligence will give a logical reasoning answer. At present, our artificial intelligence is at this stage, and in the future, will enter the era of physical artificial intelligence. This is the cornerstone of the robot revolution. For example, we tell the computer to generate 3 detailed and diverse scenes. Describe what might appear in the camera's field of view in the next 5 seconds. When we input such a problem into a neural network, through the inference and calculation of the token of the artificial intelligence factory, the first possible thing to be seen is the car's hood. Of course, it is possible that a bird will fly onto the engine, and it is also possible that a dog will be next to the car. This is equivalent to artificial intelligence being able to recognize the world. It's called physical AI, and general-purpose robots will usher in the next trillion-dollar industry. When we say to the robot, "Pick up the object made by NVIDIA, and place it gently in the drawer. Before you begin, explain each step you will take." When a user inputs such a prompt into an AI, input the robot's neural network, and through the AI factory's token, after inference and calculation, the robot will give the corresponding answer. Next, let's talk about a thinking computer, the GB300 NVL72. This is the 3rd generation artificial intelligence server of the GB series, and Grace Blackwell is the 3rd generation superchip called the Ultra Superchip, to provide 40 petaflops of floating point operations per second, equivalent to 1.5 times that of the GB200, and 576 GB of high bandwidth memory HBM3E. The transmission rate is up to 16 TB per second, equivalent to 1.5 times that of GB200, and 800 GBps of Ethernet Connect X8, up to twice that of GB200. And this time at COMPUTEX, the B200 server was also on display. GB300 server and NVLink switch. And this time, CEO Jensen Huang once again emphasized the GB300 NVL72 data center. The rack system uses 5,000 cables. NVLink transmission line with a total length of up to 2 miles. Next, we will discuss customized application-specific integrated circuits and NVLink's converged silicon intellectual property. This is called NVLink Fusion. The so-called NVLink is a communication interface, but this communication interface, it is defined by NVIDIA, so in the past, only NVIDIA chips could be used. This makes other processor manufacturers unable to use it. This communication interface connects to NVIDIA's graphics processors. So this time, the new CEO Jensen Huang announced that NVIDIA will open up customized application-specific integrated circuits can use NVLink Fusion Silicon intellectual property. That is, NVIDIA will transfer the NVLink Silicon IP. Related source code is licensed to other customized used by manufacturers of application-specific integrated circuits. In the future, many processors will be able to connect to NVIDIA's graphics processors through this NVLink. This is of course a good thing for customized chips and also a good thing for NVIDIA. This should be a win-win situation. Of course, a customized central processing unit, CPU, can also use NVLink's fused silicon IP to design the central processing unit. This way, it can be connected to NVIDIA's graphics processor via NVLink. In addition, this time, a semi-customized artificial intelligence infrastructure using NVLink Fusion was specially mentioned. That is, NVLink Fusion technology forms NVIDIA and hybrid application-specific integrated circuit AI infrastructure to achieve a validated scale-up and scale-out ecosystem. This is a single scalable hardware architecture with the relevant ecosystem partners listed below. The vertical scale-up and horizontal scale-out mentioned here refers to the server rack inside there are a lot of servers and the servers within the same rack. The communication extension between them connects more servers is called scale-up or vertical scaling. This is the printed circuit board used by the DGX One workstation, and the server expansion between racks is called scale-out or horizontal expansion. In practice, scaling out is easier, while scaling up is more difficult. Next, we'll talk about NVIDIA's unified architecture, which covers cloud AI, enterprise AI, from personal AI to edge computing. This includes AI storage servers, DGX B200, B300 servers, and RTX Pro servers, RTX Pro workstation, RTX Pro notebook computer, and GB200 and GB300's NVL72 cloud server, DGX workstation, and DGX Spark. Among them, the servers on the right use the x86 platform as the central processing unit, and the servers on the left use the ARM platform as the central processing unit. Next, CEO Jensen Huang demonstrated the DGX One and DGX Spark workstations. You will find that the volume difference is very large, and the computing capabilities of the two are different. In addition, the DGX workstation can handle 1 trillion parameters. The model is applied to a personal artificial intelligence machine. It can perform 20 petaflops of floating point operations per second, can do AI inference. Using the GB300 Grace Blackwell Ultra Superchip and Extreme Superchip, with 800 GB of unified system memory, capable of supporting up to 1 trillion parameter models using ConnectX 8 Super Smart NIC. Can provide a network connection speed of 800 Gbps per second. Below are the relevant ecosystem vendors and the DGX workstation. The one on the left is the central processing unit CPU, and the one on the right is the graphics processing unit GPU. These 8 are high bandwidth memory. Next, we'll talk about NVIDIA's enterprise AI platform, accelerate the trillion-dollar investment in global information technology. This includes the underlying hardware for computing, storage, and communication. The upper layer runs the CUDA-X unified computing architecture, which is NVIDIA's solution for different artificial intelligences. A well-written function library for customers, and AIQ, which is an integration. Accelerated computing storage platform software tools includes the new Llama Nematron inference model, which can create a digital workforce for businesses. Provides a strong foundation to break down agent silos, to handle complex tasks with high precision and speed. In addition, Docker is provided, which is a software platform for data processing units, DPUs. As we all know, a server must be connected to the network. As long as it is connected to the network, you need to run network-related communication protocols and security software. These software are all executed using a data processing unit, DPU. Docker is the relevant software platform that allows engineers to develop network communication and information security software. In addition, NVIDIA provides the NeMo software framework and Omniverse digital twin. related development kits. This whole thing is called artificial intelligence infrastructure. Below are the related ecosystem partners, and on the AI infrastructure. AI operations, AI ops, can be performed. It is the operation of combining artificial intelligence and information technology. To combine can automate daily tasks. It can also enhance security measures and ultimately achieve agent-based artificial intelligence. Below are the relevant customers using NVIDIA's enterprise AI platform. Next, CEO Jensen Huang demonstrated NVIDIA's DGX Pro 6000 graphics processor. The server on the right is manufactured by MSI and NVIDIA's RTX. The Pro 6000 graphics processor has a total of 8 Blackwell graphics processor modules running, of general artificial intelligence, computing and graphics with computing power up to 4,000 trillion times per second, of floating point operations for AI inference supporting 96 GB of GDDR7, and 1.6 TB per second memory bandwidth. This is NVIDIA's RTX Pro server. The one on the left is the motherboard and the one behind is the 8 graphics processor modules. These 4 chips are switch chips responsible for communication between the 8 graphics processors as an enterprise AI and industrial AI computing platform. This image is the test result of the Llama 70 billion parameter model. The further to the right on the horizontal axis, the lower the latency, which means for each user per second. Number of tokens that can be processed, the higher up the vertical axis, the higher the speed. That is, for every $5 million of equipment per second, the number of tokens that can be processed. The line below is the test result of the previous generation Hopper graphics processor. The line above is this generation's RTX. The test results of the Pro graphics processor show that its computing performance is 1.7 times that of the previous generation H100. This image is the test result of DeepSeek R1. The line below shows the test results using the previous generation Hopper graphics processor. The line above uses this generation's RTX. Pro graphics processor test results, the computing performance is up to 4 times that of the 100. Therefore, the test results for different models are not the same. This is NVIDIA's RTX Pro server and related ecosystem partners. Next, we'll talk about Dada's AI data platform. This rack contains AI servers for computing and storage servers for storage, and network switches for communication using such a system to serve as a question-answering AI data platform. When a user gives a prompt, it goes through NVIDIA's Llama Nematron. The inference model uses related tools to perform computation, web search, semantic query, structured database query, and generative AI, and finally give a response. This process is called NVIDIA AIQ Blueprint is the AIQ Blueprint. Below are the related ecosystem partners. Then we talk about the NVIDIA top leaderboard. Open models and datasets for customers to develop various generative AI applications. Using the Nemo Retriever framework, data retrieval can be 15 times faster. For information retrieval, the accuracy can be improved by 50%. Next, we mentioned that VAST uses Nemo Retriever framework for enterprise-related applications. It only took 3 days to use what we just introduced. The NVIDIA AIQ Blueprint achieves the desired results. Use Nemo Retriever to retrieve data from the database. After searching and sorting data in the vector database, it can also be done through the network. Search for data and finally use the NIMS library through Llama Nematron. Inference model when the user inputs a prompt. The inference model can then fine-tuning, planning, and feedback are a continuous cycle. Finally, the report and action plan required by the user are obtained. For example, an employee asks AI for the best in the Asia-Pacific region. Business opportunity to create a plan, which is a sales outline. Next, the AI agent will simulate a sales outline and use the enterprise's internal. Related databases include customer relationship management systems and at the same time search multimodal knowledge base and internal tools to integrate this data. Then use the Llama Nematron library. Convert all the previous outlines into a step-by-step sales plan. And this sales plan is not like the early AI, which was a question and answer format, but to complete all actions on behalf of humans, so it is a kind of artificial intelligence agent. Similarly, DataStax, Elastic and Nutanix, Red Hat and Trend Micro all use the same method to build an enterprise resource management system, also known as the enterprise brain. Finally, CEO Jensen Huang talked about the next trillion-dollar industry for robotics, including simulation, deployment, and training. In the future, humanoid robots will be in the home, assisting humans with household chores. According to the 3-stage scaling model, humanoid robots are currently in pre-training scaling and post-training scaling. That is, using network video to pre-train artificial intelligence. At the same time, train AI through human demonstration, and finally through post-training. Synchronized data generation and reinforcement learning entity simulation enhance the functions of humanoid robots. And NVIDIA uses physical AI and digital twins. The operating system, which is NVIDIA's Omniverse, uses digital twins to create a virtual world, combined with the local cosmos to simulate the physical world to create a large amount of data. Using these two platforms for interactive training of humanoid robots. When we train a humanoid robot, it is impossible to do all the actions. Therefore, the Cosmos platform can be used to simulate various physical world data actions. Next, use this data to train the AI model. At the same time, NVIDIA collaborated with Disney Research and Google DeepMind to release Newton, a scalable physics engine to enhance robot learning. With MuJoCo Disney Research customized software, NVIDIA Warp announces open source development framework. Used in Python to create data generation and spatial computing, forms a robot learning framework complemented by the Isaac robot software development platform. Among them, MuJoCo is a multi-joint dynamics with contact, which is a general-purpose physics engine suitable for robotics, biomechanics, and machine learning, and software development. At the same time, NVIDIA launched Isaac GR00T N1 humanoid foundation model. So, the user can input a prompt to the robot. For example, pick up industrial items and put them in the yellow trash can. These words will be converted into text tokens, and the robot receives signals through its sensors, which are converted into sensor tokens. Through the visual language model and the diffusion transformer model, it is converted into action tokens. Finally, it drives the humanoid robot to perform related actions. At present, this open-source humanoid robot foundation model, Isaac GR00T, has been downloaded 6,000 times, received 3,600 stars on GitHub, which means many customers have already started using it. And this kind of digital twin can be applied in factories to first connect the relevant machines. The equipment is simulated and verified, and construction begins only after confirming its feasibility. At the same time, this digital twin can include humanoid robots and autonomous vehicles. Delta is using such a digital twin system to plan its factory. Ywin, Pegatron, Foxconn, Gigabyte, Quanta, Wistron, TSMC, even NVIDIA uses such digital twins to plan factories or data centers. And in response, NVIDIA's team also built a digital twin of Kaohsiung City. What you are seeing now is a digital twin built in a certain area of Kaohsiung City. Create a virtual world in the computer. Finally, CEO Jensen Huang once again emphasized AI factories, AI agents, and robots all need excellent partners. You can all use HUIDA's unified architecture, which means the partners mentioned above. You can all use HUIDA's unified architecture, which is the one below. These AI server platforms are used to achieve AI training and inference goals. Finally, let's make a conclusion for everyone. This time, CEO Jensen Huang introduced everyone. In addition to the new graphics processor, he specifically mentioned the application of graphics processors in the field of quantum computing. It can assist the quantum processor in pre-processing and post-processing. It can assist the quantum processor in pre-processing and post-processing. In addition, he also mentioned general-purpose robots will be the next trillion-dollar industry. More importantly, this time he opened up the NVLink between the CPU and peripheral chips, silicon intellectual property of communication interface. Then the NVLink communication interface he authorized for other chip manufacturers to use. This can increase the usage of the NVLink communication interface. More and more chips are supporting it. Basically, this is a good thing for NVIDIA. Okay, that's all for today's show.